Okay, now we're ready to find out why radian measure is so important. Why can't we just always work with degrees? So we're in section 3.2, and we're going to break this into two parts. The first part is actually doing some geometry. We're going to find the length of an arc. So let's recall. All right? If you have a circle, all the way around the circle is called the circumference. I don't want to know the whole circumference. I want to know part of the circumference. Part of the circumference is an arc. So if I want to know an arc, I've got to put in this picture a central angle. Okay? And a central angle is formed by the radii. One radii, another radii. This is your angle. This is the length of your arc. These are your radii. Okay? Back in geometry, to find the length of this arc, how far the distance is from here to here, you would have first had to find the whole circumference of the circle. And then you would have figured out what part of the circle is this piece. So suppose this angle was 90 degrees. 90 degrees is a quarter of a circle. So you would take a quarter of the circumference, and that would give you the length of the arc. Well, there's another way to find that length a little bit quicker with an easier formula. We learned in the previous section the measure of angle theta is the length of the arc divided by the radius. We can manipulate this formula to find the length of the arc, to isolate the letter S. So if you think, here's your formula, theta equals S over R. And if I want to get S by itself, I'd have to get rid of the divide by R. We all know how to get rid of a divide by R. To move it, you do the opposite operation. You multiply by R. This would be R times theta. And over here, the R's would cancel and leave you S. So you can rewrite this formula as S equals R times theta, which in words is the length of the arc equals the length of the radius times the angle. Here's the catch. A radius is a length. It's measured in inches or feet or yards or meters. If that's a length measurement and you got to multiply to theta an angle, you can't multiply a length inches to degrees. Therefore, to work this formula to find the length of the arc, the catch is this angle has to be in radian measure, because radian measure is a number. That's an actual number on the number line. That's like a length. If the radius is 6 inches, 6 is on the number line. You can only multiply a length to a length. That's why we're going to need radian measure. So, to find the length of an arc, you have a formula, S equals R theta. Yes, I expect you to have that formula memorized. I'm not going to give it to you. You should know it's an easy formula. So let's work through some examples in your notes. Let's go to 1A. 1A says, if this is my given information, find the length of the arc. So let's look. If it says find the length of an arc, the first thing we're going to do is write down the formula. What is the formula, people? S equals R theta. Good. The formula is written down. Now we're going to fill it in what we know. If we look at this diagram, we know the length of the radius. It's 12. We know the measure of the central angle. It's in radian measure, pi over 3. How do I know that's radian measure? It's got the pi symbol in it. There's no degree symbol. All I got to do is multiply 12 times pi over 3. That would be 12 pi over 3, which we know reduces to be 4 pi. The length of the arc is 4 pi. Now, length would be in inches or feet or centimeters or meters. There's no units given on this picture, so we'd write it's 4 pi units. Now I know what you're saying. Hey, Miss Black, that means nothing to me. Guys, approximate. Pi is roughly what number? It's the whole number 3. 4 times 3 is roughly what? 12. The length of this arc from here to here is roughly 12 units. That's what you're finding. All right, let's go to example 1B. It says, find the length of the arc. Given this information, as soon as you hear the word length of arc, what formula are you going to write down? Good. S equals R theta. This information is very obvious. So they give me the radius, 15 1/10 of an inch. They give me the angle measurement, 210 what? Degrees. Here's where we got to think. Can we multiply degrees to inches. Radius was in inches. Heck no. Degrees is not a number we can work with. Just like in elementary school, you don't work with a percent, you change it to a decimal or a fraction. You have to change degrees into radians. So we're going to go over here to the side and do our conversion. From the last section, 210 degrees. To change that into radians, we're going to multiply by pi over 180. Everybody agree? What's going to happen to the degrees? They're going to cancel out. 210 over 180. Well, both numbers end in a 0, so I can divide them by 10. That gives me 21 over 18. Ooh, 21 and 18 are both multiples of 3. How many 3's going to 21? That's 7. How many 3's going to 18? That's 6. So this is 7 pi over 6. So 210 degrees is really 7 pi over 6 radians. It's equal. 5 feet, 60 inches. They mean the same thing. I can replace now in my conversion here, in my formula I'm about to work, arc length is 15 and 1/10 inch times 7 pi over 6. The directions say round to the nearest tenth. By asking me to round, I automatically know, hey, I need to take my calculator out. There is no other pi symbol in here to cancel. So I'm going to type exactly as I read this. I'm going to write the decimal, 15 and 1/10 times 7 pi, make sure you get the pi symbol, divided by 6. Let me show you what my screen looks like. Everybody see that? That's exactly what I'm typing in. I'm going to hit equals. I'm going to get a lovely number. I'm going to write the whole thing out first. I get 55.34439058. Now I'm going to round. It says to round to the nearest tenth. The digit 3 is in the tenth spot. There's a 4 behind it, which means it will stay at 3. So this arc length is 55 decimal point 3. But it will be marked wrong if you don't put units. This is a length. Arc length. Length is not radians. Length is not degrees. It's an arc length. Arc length is in inches or centimeters or millimeters or whatever. It was in inches. So I got to write the word inches. There's your answer. Okay? Let's go to 2B. 2B, here's the diagram. Well, what information are they giving me in the diagram? Well, if you look, this arc is going from here to here. So they're giving you the measure of the angle. This is what theta is. Theta is 7 pi over 4. Is that in radians or degrees? Very good. That's a radian measure. Now, on the outside here, they're giving me 14 pi. 14 pi is the length all the way around, which is the length of the arc. So we have S. So we have S and theta. So S equals R theta. We know the length of the arc is 14 pi. We don't know the radius. That's our unknown. We leave it R. We know our angle measurement is 7 pi over 4. Because this angle measurement's in radians, we can work with it. It's a number. Now, guys, just use your arithmetic skills. How do you get R isolated? How do you move the fraction 7 pi over 4 over to the left side? You multiply by its reciprocal, which is 4 over 7 pi. What I do to the right, I do to the left. Everybody's good? Simple rules of solving a linear equation. What's going to happen here is the 7 pi and 7 pi are going to cancel. The 4 and 4 are going to cancel. You're dividing. You're left with good old R. Over here, the pi and the pi are going to cancel. 7 goes into 14 twice. So that's 4 times 2, which is 8. So this radius is 8. They don't give any measurement, so we're going to write units. If they don't give an actual measurement, then just write the word units if it's a length measurement. Everybody's good? All right, let's work one more example in the notes together. Let's look at example 3. So there's a picture. Obviously, we don't know what the angle theta is. We know 20 is from here to here. That's the length of the arc. That is S. We know the radius is 10. So the directions say on this one, find the angle measurement. So again, the formula is S equals R theta. The length of the arc is 20. The radius is 10. we want to solve for theta. So to solve for theta, we divide by 10, we divide by 10. 20 divided by 10 is 2. 2 equals theta. I'm just going to rewrite that as theta equals 2. Sweethearts, do you see a degree symbol anywhere in here? Heck no. Then don't put a degree symbol. When you divide a length by a length, then the angle measurement is in what units? It's in radians. So there's no symbol for radians. If it makes you feel better and you want to write the word radians, be my guest. I know what you're thinking. You're saying, Miss Black, there's no pi. Radian measured does not have to have a pi symbol. Normally it does. Radian measure means the angle is a number. Is 2 a number, sweeties? Yes, it is. So radian measure. Now, it says to take that radian measure and convert it to DD. What does DD mean? Decimal degrees. So the first thing you got to know is how to change radians into degrees. So if we have 2 radians, we got to do our conversion from the previous video. How do we change radians into degrees? We multiply by 180 degrees over pi. I know what you're saying. You're saying there's no pi symbol to cancel with. That's fine. That's why we need our calculator, because it says rounding to the nearest tenth. So everybody type in exactly as you read this. 2 times 180 divided by pi. This is what your screen should look like. Okay? Hit equals, get out a decimal. 114.591559. Guys, everybody look at your conversion. You see the pi, you see the degree symbol? There was no degree symbol to cancel with it. This has a degrees on it. So this is decimal degrees. There's a decimal point. Now round it to the nearest tenth. 5 is in the tenths. There's a 9 behind it, so it should round up. So approximately, this is 114.6 degrees as DD form. It says one more thing. It says now change it to DMS. Well, again, we've already learned in a previous video, how do you take DD and make it DMS? Very simple. You just put the decimal in and hit the DMS button. Here's the catch. Do not use a rounded answer to get the next answer. It will be off. Anytime you're going to take an answer from one part and use it to get an answer to the next part, you have to use the whole thing. So you have to use this whole decimal degrees. So look, I left it in my window. There it is. It's in my window. Now all I got to do is go get my DMS button. And when I hit DMS and hit equals, I will now have degrees, minutes, seconds. This is 114 degrees, 35 minutes, 30 seconds. I don't have to do any rounding because there's nothing behind seconds. So again, when you're converting from DD to DMS, do not use your rounded answer. This will be off. Always use your exact decimal degrees. All right, we have one more section to cover to see why we need radian measure. I'll catch you in the next video.